My name is Sean Howe. This is Fundamentals of Physics, month 1508, instructor Raul Vargas. This month we are learning about all kinds of different formula for physics. I chose light to be my video project. Early on we had learned that angle incidence, or the angle in which the incident ray is entering a mirror, is equal to the angle reflection. So that if the incident ray is 50 degrees, then the reflected ray is 50 degrees. But I'm still left wondering, what is the formula for expressing this in different mediums? Say, the reflected light or refracted light from water or other mediums, just other stuff. Well, upon investigating on the internet and trying to find a useful formula, I found Snell's law. Now, Snell's law helps explain how light from air has an index of refraction of 1.0 and an index of refraction of water at 1.3. But the formula for sine is the n1, or index of refraction for n1, times sine of theta 1 is equal to the index of refraction times sine of theta 2. What I did is plugged in the index of refraction and the angle degree, and then did some math. I came up with a 30 degree angle for the refracted light, and hopefully this makes sense to everybody because I'm not very good at explaining it. But with the explanation, I'm also going to do a little experiment to better help explain what I'm talking about. And for this experiment, I'm going to use a cup of water. And in that cup of water, we're going to put a straw. Thank you, Grant. Alright, now this is pretty common. We see this every day. You put a straw in a cup of water, and the reflection gets skewed. Now, although the numbers that I showed you in this theorem aren't exactly for this exact experiment, it does help give us a point to better understand it. As you see, with the straw within the water, that the angle is askew for the upper part, with a break and the reflection here. As we turn the jar and glass, we can see the refraction of the reflection gives us some pretty crazy views of the straw within the water medium and the glass. Pretty cool, huh? Well, me and my kids think so. Huh, Grant? Mm-hmm. But Snell's law, definitely helping to explain this. Now, what's the point of Snell's law? As a video game artist, I would like to better explain the world around me and how these things work within a simulation. So as a game artist, it's good to understand physics so that you can express these things that happen in real life. Hopefully this was helpful, and thank you for your time. Goodbye.